Hey, my name's Kyle, and today with my partner Andrew, we're going to be talking about the study of motion. Okay, before we start, we have to understand just what physics is. So I'll talk about that now. So what is physics? Physics is the branch of science concerned with the properties of matter and energy and the relationships between them. Physics is also based on mathematics and traditionally it includes mechanics, kinematics, and dynamics, which we'll get into later, optics, electricity, magnetism, and heat.
First is kinematics, the study of motion itself, not the forces that produce the motion. Second is dynamics, which is also related to kinematics. It's the study of the forces that produce motion.
Alright, generally quantities or measurements that can be made up into two categories. Those two categories are scalar and vector quantities. First is scalar, which is a quantity that has magnetism only, which only talks about magnetism. So when we're talking about just a certain distance, that's what scalar is. Next up is vector, and that's a quantity that has a magnetism size and also a direction. So when we're talking about a distance and what direction it would be. So for an example, 2.2 meters in the direction of west.
First, we're going to talk how do we denote a scalar quantity versus a vector quantity. Let's use the distance and displacement as an example. Distance would be denoted as d. Displacement would be denoted as delta d. The difference is the half or full arrow put over top the variable.
So how do we calculate the change in position? So in order to get the displacement, what we would do is get the finishing distance minus the calculated distance. And if an object changes its position more than once, the following equation could be used. Distance total equals distance 1 plus distance 2, and I'll get the total of displacement and distance.
In addition to the algebraic method used to calculate displacement, when dealing with straight parallel lines, there's another method using vector scale diagrams that can prove useful. One of them is vector scale diagrams. It's drawing to scale in the correct direction, so when you're drawing a vector scale, you pretty much use all arrows going in one direction.
What also is a part of the vector scale diagram is the directed line segment, and basically what that is a straight line going in the direction and the position.
We also use instantaneous speed, which is the speed at a particular instant. It is also a scalar quantity. Second is average speed. It's the ratio of the total time of travel, so it is also a scalar quantity as well.
What's also related to what Andrew just said is instantaneous velocity and average velocity. And basically what this is well, instantaneous velocity is the velocity at a particular instant. It is the rate of change of position, and it's also a vector quantity. Next is the average velocity, the ratio of displacement to the time interval for the displacement. It is a vector quantity as well. Next up, we have acceleration and constant acceleration. So basically what acceleration is, it's the rate of change of velocity. And it's a vector quantity as well. Next is constant. So constant acceleration is a straight line motion in which the speed changes by the same amount each second. And then there's average acceleration. It's the change of velocity divided by the time interval for the change. And it's also a vector quantity. What's also related to acceleration is free fall. And basically what this is the acceleration of an object near Earth's surface if air resistance is ignored. So, and the average, which we use in calculations all the time, the average is delta gravity, which is 9.8 meters per second squared.
So now we're going to talk about forces. So what is a force? It is a push or pull motion, and it is also a vector quantity. So there are different forces that we use from daily basis. First one is gravity, and what is gravity? So it's the attraction between all objects, only noticeable if at least one object is huge. Next is applied forces, which is a general name for any object force. Next one is normal force, which is the force at right angles to object in contact. Friction, which is the force between objects in contact. It is parallel to the contact surfaces and acts in a direction opposite to any motion or attempted motion. Next is static friction. Static friction is the force that prevents any stationary object from starting to move. Next is kinetic friction, which is the force that acts against an object motion. Next is air resistance, which is the friction on an object moving through air. Last but not least, which is tension. It's the force exerted by strings, ropes, fibers, and cables.
So those forces he mentioned, there has to be a way to illustrate them. Luckily, we have two, a system diagram and a free body diagram. So first is a system diagram, and basically what that is, it's a drawing of all the objects in the situation under analysis. And then next is the free body diagram. It's a drawing of just the object being analyzed, not the entire situation, that shows all the forces acting on the
Next,
object.
we're going to talk about inertia, which is Newton's first law of motion. So what is inertia? Inertia is a property of matter that causes an object to resist changes in the state of motion. It is directly proportional to the mass of an object. Examples of inertia is when you're driving a car or using the brakes when driving a car. Next thing is net force. What is net force? So net force is the vector sum of all the forces acting upon an object, also called the resultant force.
So we can basically summarize what Andrew said with these few points. First, objects at rest remain at rest unless acted upon by a net force. Second, objects in motion remain in motion unless acted upon a net force. Third, if the velocity of an object is a constant or zero, net external force acting upon it must be zero. And lastly, if the velocity of an object is changing either in magnitude, direction, or both, the change must be caused by a net external force on an object.
So now we're going to talk about Newton's second law of motion. So Newton's second law of motion is if the external net force of an object is not zero, the object accelerates in the direction of the net force. So the magnitude of the acceleration is directly proportional to the net force and inversely proportional to the object mass.
Next is weight versus mass. So even though weight and mass are used interchangeably in daily life, they're actually quite different quantities. So weight is the force of gravity on an object. It is a meter quantity measured in newtons. Mass is the quantity of the matter in an object. It is a scalar quantity measured in kilograms.
So Newton's second law describes quantitatively the relationship between a net force and the acceleration of a mass. But where does the force come from that is exerted on an object? So that's where Newton's third law kicks in, and it's for every force, there's a reaction force equal in magnitude, but opposite in direction.
So next up is friction. There's multiple types of friction, so I'll go over each. So first, just friction is the force between objects in contact. It is parallel to the contact surfaces. Next up is kinetic friction, which is the force that acts against an object's motion. And then next, after that, is static friction, which is the force that prevents a stationary object from starting to move. But now, how do we limit static friction? The force needed to counteract friction and start an object moving. When the force applies increases from zero to the value needed to start the motion, the force of friction opposing the motion must also increase. Otherwise, the object will start to move. Next is the coefficients of all the three frictions. So first is static friction, and this is the ratio of the magnitude of the maximum static friction to the magnitude of the normal force. This maximum occurs just when the stationary object begins to move. Next is the coefficient of friction, and it's the ratio of the magnitude of the force of friction between two surfaces and the magnitude of the normal force between the surfaces. And then lastly, we have the coefficient of kinetic friction, which is the ratio of the magnitude of the kinetic friction to the magnitude of the normal force.
So that covers the study of motion me and Kyle talked about, and thank you for watching.